Hello everyone. Today let's solve the problem Vasily's multiset. Right. So this was asked in the Codeforces round 367. This was asked in the Codeforces round 367. So what the question states here, you can just go through the question. It is very easy to understand. You can just go through the question. This is it, right? It is very easy to understand. This is nothing but the input output, but right. So you can just go through the question. It is very easy to understand, right? So um, what the question states here, I'll just summarize the question so that it will be easier for us to solve the problem, man. Right? So what the question states here, we are given a multiset A. We are given a multiset A. Here, just give me a second. Yeah, we are given a multiset A. So just give me a second. 1 second. Yeah, we are given a multiset A, and this one initially containing 0. Initially containing 0. A is a multiset which initially contains 0, and Q is the query of 3 types. Q is the query which consists of the 3 types, right? So Q is the query which consists of 3 types basically. One is here you can consider plus x, and another one is minus x, all the arithmetic operators, right? Plus, minus, and the last one is this one, question mark x, question mark x, right? So here plus x means we have to add the integer x to the multiset A. We have to add the integer to the multiset A. So what is minus x? Here minus x is we have to remove one occurrence of x from the multiset A. We have to remove one occurrence of the this one. We have to remove one occurrence of x from the multiset A, and the third one is question mark x. For a given integer x, we have to print the maximum value of x XOR y. So this is nothing but the XOR symbol. This is nothing but the XOR. So we know that, right? So in the mathematics you would have used this symbol plus within the round, right? So this is nothing but the XOR. We know the same thing in the programming languages. We make use of this symbol, right, for the XOR. XOR means, if I correctly remember, so only when two integers are different, suppose 0, 1, 1 and 0 will lead to 1, will lead to 1. So, and this one, 1, 1 and 0, 0 will lead to 0, will lead to 0. This is basically truth table of the XOR, right? This is nothing but the truth table of the XOR, right? So we are given a multiset A initially containing only 0 and Q, queries of 3 types, right? So one is here plus x, one is plus x, another one is minus x, and the third one is question mark x. Third one is question mark x, right? So here in this case, plus x means here we have to add the integer x to the multiset A. We have to add the integer to the multiset A. Minus x means we have to remove one occurrence of x from the multiset A. We have to remove one x from the multiset A. Means we have to remove one occurrence of x from multiset A. And the third one is for a given integer x, we have to print the maximum value of x XOR y. We have to print the maximum this one value of x XOR y, this one where y is any number in multiset A, where y is any number in multiset A, y is any number in multiset A, right? So I hope the question is clear. What we should do, we have to answer each this one, question mark x query. We have to answer each question mark x query efficiently. We have to answer this part, man. Question mark x query, right? We have to answer each question mark x query efficiently. We have to answer this question mark x query efficiently, right? Just keep this in mind. Just keep this in mind, right? So we have to answer this question mark x query efficiently, right? So this is about the question. This is about the question. Easy to understand, right? So I'll just read out this one loud once again. Just listen to this. We are given a multiset A initially containing only P and Q. Only 0 means initially A containing 0, and Q is nothing but the queries which contains 3 types, which is of the 3 types basically. Plus x, nothing but we have to add the integer x to the multiset A. Minus x, nothing but we have to remove one occurrence of x from the multiset A. And question mark x, nothing but for a given integer x, we have to print the maximum value of x to the power of y, where y is any number in the multiset A, where this one y is any number in the multiset A. We have to answer each question mark x query efficiently, right? So we have to answer each question mark x, this one, efficiently. We have to answer this question mark x, this one, query efficiently, right? We have to answer this question mark x query efficiently, right? So this part. So this is fine. Let's come to the input output part here. Let's come to the input output part here. We have here 10 inputs. They have given 10 inputs in the first line. Just give me a second here. We have 10 inputs. You can clearly see 10 they have mentioned. This one plus 8 plus 9 plus 11 plus 6 plus 1. We don't have to worry about this one, right? Plus 1, this one. Basically, we have to find for the question mark, starting with the question mark, basically, right? So question mark 3, for this we have to get the output 11. We have to again this one subtract this one minus negative, this one we don't have to worry about, right? This one, what we are doing here, plus and minus means same, this thing. For the plus, we have to add the integer x to the this one multi-set a. Minus x means minus 8 means we have to remove one occurrence of x from the multi-set a. So return value will be nothing, null here in this case. So for this one question mark 3, we have to get the output 11. And for the question mark again question mark 3, this one they have given, right? Again we have to get the output 10. And for the question mark 8, we have to get the output, this thing, what do we call, for the question mark 8, we have to get the output 14. And for the last one, the question mark 11, we have to get the output 13. We have to get the output 13. So the output that we need to get here is 11, 10, 14 and 13. This is for the question mark 3 accordingly with the operations after these operations, plus 8 plus 9 plus 11 plus 6 plus 1. After these operations, this plus 6 indicates that we have to add the integer x to the multi-set a. Minus x or the negative x means we have to remove one occurrence of x from the multiset a, nothing but guaranteed to access. The question mark x means this one, we have to for a given integer x, we have to print the maximum value of x or y, where y is nothing but any number in the multiset a. So this is question mark 3, and this part is again question mark 3. This has to lead to 1 0, and the last two is this one, what do we call, question mark, just give me a second here. Question mark 3. Oh, yeah. Question mark 8. And this one is question mark 11. This part. Question mark 11. Right. So this is fine. Question mark 3, because we have to subtract this one, right? So this one 3, 3, 8, 11. Right. So here we got 3 for 3, 3, 8, 11. The output has to be 11, 10, 14, and 13. This we will see in the approach. I hope the input output part and the question is completely clear first, right? Easy one, right? First, what shall we do? Let's discuss the approach followed by the this one, followed by the complexities, and then let's write the code, and then let's write the code. Initially, let's discuss the approach first. Here I have considered the same first example that they have given in the question, right? So we have already discussed this one. Here we have plus 8 plus 9 plus 11 plus 6 plus 1, and this one, for this one question mark, starting with the question mark, we have to calculate this one, right? Question mark 3, 3, 8 and 11. For this one we have to get the output 11. We are performing the subtraction operation, nothing but here in this case. Plus means, again I'm telling, again I just want to tell you what does plus and minus do here. Plus x means plus x here. It means we have to add the integer x to the multiset A. We have to add the integer x to the multiset A. Minus x means we have to remove the integer x. We have to remove one occurrence of x from multiset A. We have to remove one x from multiset A. This part I'm speaking of. This part I'm speaking of, right? So here we have to add the x to the multiset A, and we have to remove one occurrence of x from the multiset A, right? So this one will give us the output, this one, what do we call, after performing these operations we get the output 11, 10, 14 and 13 accordingly with the input. So let's go with the step-by-step explanation here. Let's go with the step-by-step explanation here, right? So just give me a second, 1 second, man. Just give me a second. So did I miss anything here? Did I miss anything? No, right? So here yeah, multiset starts with this one 0. multiset starts with 0 basically, right? First let's multiset starts with 0. Just remember this one. Remember we have 0 8 9 11 6 1, 8 9 11 6 1, right? So 8 9 11 6 1, multiset always starts with a 0. Just remember this point, this is very important, right? So or else you'll not get to know why we have made use of the 0. I'm stressing on it. Multiset starts with 0. After additions it would be 0 8 9 6 1 accordingly with the input. The first input I'm considering, the first example we are considering here, right? So for the question mark 3, max XOR with 3 we have to consider means 3 with 11, this one, 3 with 6, 3 with 11, 3 with 9 and 3 with 8, these four things, right? So these four things. So with multiset starts with the basically 0, and after addition we get 0 8 9 11 6 1, right? 0 8 9 11 6 1. So we will be going with the max XOR with 3. Max XOR with 3. We go with 3 XOR 11, 3 XOR 6, 3 XOR 9 and 3 XOR 11. So I can just convert this to binary and check, man. So this will lead us to the output 8 5 10 and 11, and maximum we have to consider, maximum among 8 5 10 and 11 is 11. So I can just check this one if you want, right? So you get the output 8 5 10 and 11. The maximum that we need to consider maximum over here, so the output that we got here is 11. So the output that we got here is 11, right? So this is fine. The next part here would be, we have to go with the minus 8 now. Minus 8 means we have to remove one occurrence of x. We have to remove one occurrence of x from the multiset A. One occurrence of this one from the multiset A. So we will be removing 8. We have 8 9 6 8 9 sorry 11 6 1, right? So 0, as a multiset starts from the 0, and we are removing one occurrence here. We are removing one occurrence of x from the multiset A. We will remove this one, 8. Now we are left with 0 9 11 6 1, 0 9 11 6 1. So here we have question mark 3 again. We have question mark 3 again. So max XOR with 3, this one 9, first one 3 9, this will be 10. So the output is 10. So the output is 10. Now we have question mark 8, 8, this one 8 XOR 6, 8 XOR 6, this one XOR 6, 8 XOR 6, right? So now the maximum we have is 14, and finally 11 XOR 6, we have 11, question mark 11, 11 XOR 6, again we will get the maximum 13. We'll get the maximum 13. So we got 10 here for this, we got 14 for this, we got 13, and previously we had got 11 as well. If you remember, just give me a second. From the previous one we went with the this one, maximum we had was 11, so we went with 3 XOR 11, 3 XOR 6, 3 XOR 9 and 3 XOR 8. The same thing we are doing here as well. You can just check with the 3, right? So you can just check with the 3. 9 will be maximum this time, second maximum this time. So we will be considering second maximum. We'll be considering second maximum. For this one, the third maximum is 6. After 9, the third maximum will be this one, 6, right? So here in this case we'll be considering 6. 11 we already considered first maximum, and second maximum was 9, and the third maximum was 6. Third maximum was 6. Here 6 we went for the this one, 8 and 11, 8 and 11, 8 XOR 6, 11 XOR 6. The maximum that we got here is same thing. You will go with the maximum for everything like this, as we considered like this one, right? So this will be, maximum will be 10 for this one, the maximum will be 14 for this one, and maximum will be 13 for this one. So total it will be 11 10 14 and 13. The output that we got here is, accordingly with the approach that we went with, is 11 10 14 13, 11 10 14 13, which is equivalent to the output that they have mentioned for the example 1 in the question, 11 10 14 13. So our approach works absolutely correct in this case. Our approach works absolutely correct in this case, right? So our approach works absolutely correct in this case. Now as we are completely familiar with the approach, we can do one thing. Let's carry on with the, or let's move on with the complexities part. Now as we are completely familiar with the approach, let's move on with the complexities part. Just give me a second here, 1 second. What happened to this one? Yeah, let's move on with the complexities part. So what will be the time complexity? The overall time complexity would be big of q. See, for each operation, this one, as we are going with plus, minus, and we are going with a question mark symbol, this one as well. For each operation, this one, adding x to the multiset A, adding x to the multiset A, removing x from the multiset A, and this we have to go with the XOR, perform XOR, right? Perform XOR, these three things. Each operation, this one, each operation, this one takes big O of 31, takes big O of 31, which will lead to big O of 1 effectively, since each integer bits are constant here. Each integer bits are constant here. So we can consider for the each operation it is big O of 1. Nothing, because here integer bits are constant, we can consider big O of 1. So total complexity would be big O of q. Total complexity would be big O of q here, where q is nothing but number of queries. Where q is nothing but number of queries. Where q is nothing but number of queries here. Where q is nothing but number of queries here. This part I'm speaking of, where q is nothing but number of queries, right? So here this is fine. uh, each operation takes big of 1 effectively, since integer bits are constant here, and total complexity is nothing but big of q here. Total complexity is nothing but big of q here. So here this will q is nothing but the number of queries, sorry, nothing, q is nothing but the number of queries here. So overall total complexity, or the overall complexity, would be big of q. So what will be the space complexity here? The space complexity would be big of n into 31, because each inserted number uses up to 31 try nodes. So we will be going with, again, one thing I didn't say here, we will be going with the try data structure for this one. We will be going with the try approach. Basically, in simple terms, we will be going with the try approach to solve this particular problem, right? So each inserted number uses up to 31 try nodes. In the worst case, it can go up to big of n into 31. In the worst case, it can go up to big of n into 31. N into 31. N is nothing but the number of unique elements here. N is nothing but the number of unique elements. Each number can go up to this one. Each inserted number uses up to 31 try nodes. In the worst case, big of n31, n into 31, right? So n is nothing but the number of unique nodes here. So overall space complexity will be big of n into 31 for this case, in this case, right? So the time complexity would be big of q, and the space complexity would be big of this one. What do we call? N into 31. Just give me a second, 1 second here, 1 second, man. Yeah, because n into 31 here, because n into 31, right? So this is it for the complexities and the this one, what do we call, approach part. As we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So let's start writing the code here. The first step here would be, we'll be making use of the input output, means fast input and output, buffer reader and print writer. So we have to go with the input output package. Also we'll be making use of the utilities. So let's go with the util as well. So here I'll just import java dot input output dot star. So this is fine. Next, let's import here java dot util dot star. So this is fine. Next, let me go with the class, this one, main. This is fine. Within the main class, so we have to go with the try node that represents each binary bit, nothing but path 0 or 1. So we have to go with the try node that represents each binary bit path, right? So either it can be 0 or the 1. I have already shown you the this one, what do you call, uh truth table, right? So here let's go with the try node that represents each binary bit path, right? So here it would be easy. So this will be static class. I'll just go with a try node. So this is fine. Within the try node class, what shall we do? I'll just go with try node. Try node. This will be child equals new. This will be try node of 2. New try node of 2. This is fine. So the next step would be, this is for the bit 0 and bit 1, and next we have to go with the count, means how many numbers pass through this node. We have to check how many numbers pass through this node. In this case it would be int count, int count, right? So this is fine. So the next step would be, let's go with the try node. Let's go with the try node. This is fine. Let's go with the try node. This is fine. So here this would be child of 0, as we had to perform three operations right here. So this will be child of 1, and also we have to set this one to null initially. Let me go with null, and also here as well let me go with null, and the third one here, let's assign the count to 0. Let's assign the count to 0. This is fine. Let me come out of this one entirely. So let me go with the class try now. So I'll just go with static class try. So within this class, let's perform the try operation. So here, usually for most of the problems in the try, we will be going with the insert remove. These two are common. These two are common. Similarly to the segment tree and fen victory, there are certain operations that are common if you are making use of the class. Heapify down, heapify up, this one, right? Bubble up, bubble down. So these operations are common. Certain operations are completely common in the heap. Certain operations are completely common in the this thing segment tree, whether it may be this one BIT as well, fen victory or the BIT binary index tree. Same thing goes with try as well. Certain things are very common. This one, insert and remove are the most common operations in the try. And also I want to tell you one thing. So whenever we are going with the try problems, usually try problems are not asked in the data structure interviews. It will be usually, you can be asked basically, but usually it will be asked in the system design interviews, right? So here in this case, let's move on with the further things here. So first thing it would be, we'll be going with the insert, right? So before going with the insert operation, uh, or the insert method here, so let's do one thing. Let's write here try node. So this one root equals new, this one try node. This is fine, new try node. So let me go with tree here, try node. This is fine. This is fine. So this one will be final int. So this one has to be max underscore bit, max underscore bit. Let me initialize this one to 30. So now let's insert the number x into try. Let's insert the number x into the try. So this will be void insert, void insert. So insert of this one int x, as we are inserting the number x into try. First thing, the same thing. Let me copy this one, try node root, this one, and let me paste it over here. So instead of root, let me consider node here, and let me assign the node to this one. What do we call root? Let me assign the node to root here. This is fine. After this step, we have to go with the for loop. Means we have to go from MSB, most significant bit, to LSB, least significant bit. So we are going with the most significant bit to least significant bit. If you don't know what I am doing, please do look into the problems that we have solved in lead code, the try lead code problem. So we have discussed this one many times, and also we have solved n number of problems in the Node.js using try. Basically, we have made use of the try for the particular problems as well. So we solved only graph in the Node.js. So I have solved most of the problems, but in the YouTube I have solved certain problems on graphs, dynamic programming, as well as the segment binary tree, binary index tree. So this one, or the fen victory. So these three topics mainly I have covered in the YouTube using Node.js. We have solved n number of problems. You have to know the most significant bit, you have to know the least significant bit, you have to know the what are the try operations, why this one, the most this one, mostly used operations in try, mostly used operations in max heap, min heap, mostly used operations in segment tree, binary index tree. Also you have to have the idea on the sparse table as well, right? So I'm not saying you have to know everything, but you have to know the concepts, these concepts, the basics of it, right? At least you have to know the most basics of it, and you have to know XOR operations, you have to know the truth table of it, right? So these things you have to know at any cost, right? So it will be really handy when you are solving problems on try, right? So these things. So for the graph, you have to know most of the things. When it comes to graph and DP, you have to know most of the things. I'll not say no, but at least to solve the try problems, you have to know these things what I have mentioned, right? So you have to know these things, right? So let's move on with the further things. Now we have to consider 31 bits. Since why we are considering 31 bits, I have mentioned in the time complexity as well, time complexity and the space complexity, right? So in the time complexity, for each operation it would take big of 31, nothing but it will lead to big of 1, but the total complexity would be big of q. We have discussed this one, right? So why we are considering 31 here? Because 10 to the power of 9 fits within the 30 bits. 10 to the power of 9 fits in 30 bits, right? Fits in 30 bits. So I can just write in this way. So I have already written this one, right? So we are with this part. So now uh, I had to consider this one. We have to consider from max significant bit to the this one least significant bit, right? So let's go with the iteration part here. For int I equals, so for int I equals, this one will be max underscore bit. This one is fine. I greater than or equal to 0. So this one will be I minus. So this is fine from the most significant bit to the or max or most, from the most significant bit to the least significant bit we have considered. Right now we have to extract the ith bit. We have to extract the ith bit. For extracting purpose, we will be making use of the ampersand, or we will be making use of the right shift operator basically, mainly. So this will be, I can write in this way, int bit equals x I ampersand 1. So this is fine. So the next step is, if node dot child this one of bit, so this one, if it is equal to null, if it is equal to null, then what we need to do, we have to create the node. If it doesn't exist, means I can write in this way, node dot child of this one bit. Let me assign this one to new try new try node. So this is fine, new try node, this is fine. So we are just creating the node if it doesn't exist. So let me come out of this one entirely. So the next part here is, we have to move to that bit path. We have to move to that bit path, means I have to assign node to node dot child of bit. This is fine, child of bit. The next step is, after moving to that bit path, we have to increment the count for this path as well. So I can just go with node dot count. We have to increment, means double plus here. So this is fine. Let me come out of this one entirely, means insert operation or insert method entirely. Now we will be going with the remove method, means we have to remove the number x from the try. Insert for plus x, insert operation for, this is for plus x. So now the second operation was minus x. We have to remove one occurrence of the x from the multiset A. This also we have to add one operation of x to the multiset A. Here we have to remove one operation, this one operation from the x. So I forgot this one, man. One operation itself, right? So I completely forgot this one. We have to remove one occurrence of x from the multiset A. This is fine. Yeah. Mm, this is fine. Just let me delete this one. So let's move on with the remove operation here. Let's move on with the remove operation. So here, how can I write this one? I can write in this way. So I'll just go with void remove. This one will be int x. This one will be int x. X is nothing but the parameter here. This one will be try node. This one will be node equals root. This one will be node equals root. So this is fine. Let's go, or let's move on with the for loop here. This one will be int I equals max bit. This is fine. I greater than or equal to 0. This is fine. I minus. So this is fine. So within the for loop, what we will do, let's go with bit. Let's assign this bit, this one x, right shift operator I, and this one ampersand 1. The same thing we are performing, man. See, same thing we are performing, right? So again, we will go with node equals node dot child of bit, similar. And instead of incrementing, as we are removing one occurrence of x, we will be decrementing the count. In simple terms, we will be decrementing the count as we remove the path. So instead of incrementing, we'll go with decrement. This is the only difference basically, to be frank, in the remove. So I'll just go with node.count uh, minus minus, right? So this is fine. Let me come out of this one entirely. We are done with the add and remove operations, right? Now, along with add and remove or insert and remove, we will go with the maximum XOR value, because we have to calculate the XOR value and we have to get the maximum out of it. Accordingly, with the approach we are going, same thing, whatever we discussed in the approach, the exact thing we are articulating in the form of code. We have to get the maximum XOR value for the number X with any number in the try. We have discussed same thing in this one approach as well. So let's go with something this one, something related to the XOR means the this one class name I'm speaking of, or the method name I'm speaking of basically, right? Here I can just give int, let's consider get max XOR. So this one will be get max XOR. This is fine. So let me pass the parameter int x here. So within this method, first what we will do, let's go with the try node this one root. Let me copy this one. This is same for three operations, right? So this is same for this one. What do we call? Insert, remove, and get XOR. So here we have to get the result. We have to store the result somewhere. I'll consider the answer or the result variable. I'll just go with res and let me initialize this one to 0. Again, same thing. This one for loop. So this remains same thing, man. So let me go with here. Let me copy this one. Let me paste it over here. So this is fine. Within the for loop, what we will do, again same thing. This one, this part. So if you would have listened to insert part, other two parts is same, and here we are decrementing instead of incrementing, as we are removing the path, right? So we are removing from the path. Next, we are just getting the we are performing the XOR operation and we are getting the maximum value here within the get max OR method, right? So here in this step, next step is for maximum XOR, we want the opposite bit as well. We want the opposite bit because as we had discussed in the this one truth table, only this one, what do we call, only the different numbers will lead to 1. 0 1 will lead to 1, 1 0 will lead to 1, right? So 0 0 will lead to 0 itself, 1 1 will lead to 0. This is XOR. We have to know this one at any cost, right? So further we'll be solving the problems on bit manipulation as well. I insist you to, if you are following along with me, I insist you to know about the OR, uh, OR operations and operation, this one XOR, these operations you have to know, man, at any cost, right? So this is simple basically, and some more operations as well. Just try to go through the bit manipulation topic and just try to uh, have this one, have the understanding on it, right? So I insist you to go through the bit manipulation topic, theory part, right? So this is fine. Next, what we will do, I have assigned opposite to 1 minus bit. So I haven't assigned yet. This one, let me do it. Then, so I'll just go with int opposite equals 1 minus bit. Int opposite equals 1 minus bit. So this is fine. Opposite equals 1 minus bit. 1 hyphen bit basically. So this is fine. So the next step is, let's write the simple if condition here. If node dot child of opposite, node dot child of opposite, if it is not equal to null, and node dot child, so this one of opposite, so this one dot count, if it is greater than 0, if it is greater than 0, then let's go with the result for this one equals to, let's go with the left shift operator, as we have to set the ith bit in the result. We have to set the ith bit in the result. We have discussed this one in the approach. Let's articulate the same thing in the form of code. This will be, as we are setting the ith bit in the result, I can just make use of the left shift operator and go with the I, right? So this is fine. One left shift operator I. So after setting the ith bit in the result, what we need to do, we have to take the optimal path. Means we have to consider the maximum value, right? So we have to consider the maximum value, or we have to take the optimal path here. So let me assign node to node dot child of, within the array I'll just go with opposite. So I hope this part is completely clear, man. This part is completely clear. So else what we need to do, we have to fall back if the opposite bit path doesn't exist at all. So I just go with node equals node dot child of this one bit, node dot child of bit. This is fine. Let me come out of this one entirely. So here finally we have to return the result. Finally we have to return the result, right? So these are the three operations that we considered for this one. These are the three try operations that we considered accordingly with the question. So we went with insert, we went with remove, we went with get max XOR, because we have to go with the maximum XOR value. So we have to calculate maximum. If you remember in the question, they have asked if question mark, if it starts with a question mark, right? Question mark x something, we have to calculate the x XOR y. We have to calculate x XOR y. So that's what, to do this one, we are going with the get max XOR method, right? Remove and this one insert is for the first two operations. This one is for the plus x. We are adding the x to the multiset A. We are adding one occurrence of x to the multiset A. Here for the minus x, we are removing the one occurrence of x from the multiset A. So this part we have already discussed, right? So this is, we are calculating the this one x XOR y if it starts with the question mark x, right? So I hope this is completely clear, easy to understand, right? So let me come out of this one entirely. Now let's move on with the main function. Let's move on with the main method or the main function, right? So here let me give main. So here let me remove this part entirely. So here let me go with throws input output exception. Let me go with throws input output exception. So within this main function, so what shall we do? Let's go with the buffered reader and nothing but the fast input and the fast output, buffered reader and the print writer. So I'll just go with buffered reader. So this one let me consider br and let me assign this one to new. So this one will be buffered reader. So this one will be new input stream reader. This one will be input stream reader system dot in. So system dot in, this is fine. So next let me go with the print writer. Print writer. So let me go with the out equals new print writer. So this one will be new buffered reader. This is not the buffered reader, man, writer, right? So I got confused here. This is fine, buffered writer. So new, instead of the input stream reader, this will be output stream writer. So this will be output out. So we have to give output entirely. So this is output stream writer dot out dot out, and not output stream dot. So this has to be, sorry, I got confused. This one has to be system dot out. So this is fine. I hope this part is fine. The next thing is we are done with the input output part. So let's do one thing. We have to go with the number of queries, right? So we have to go with the number of queries. So I'll just initialize q to integer. So this queries consists of this one. What do we call? Integer, right? So I'll just go with the integer dot. This one will be parse and we have to read. So we have to read the input. So I'll just go with the buffered reader dot read line, individual line, right? So I'll just go with buffer reader dot read line. So we have to read the number of queries. We have to read the number of queries. So I am going with this one. I have initialized q to this part. So next we are going with a try. We are going with the approach try, right? So I'll just go with the try variable here. I go with try, new try. So this is fine. The next part is initial condition. If you remember the approach, it is 0. 0 is all with the always in the multiset. The multiset starts with the 0, right? We discussed this one in the approach. I said this one crystal clearly that multiset starts with the 0, means 0 is always in the multiset. Just remember this one. So how can we articulate in the form of code? The same thing. I'll just go with insert try dot insert of 0. Try dot insert of 0. This is fine. So now let's go with the hash map, because we have to handle the multiple same elements. We have to handle the multiple same elements. So let's go with the hash map, right? So I'll just go with map. So this one will be integer. comma. So this we are considering two integers, right? As we are dealing with a hash map. So this is fine. Why this is not in green? So yeah, this is fine. Just give me a second here. Let me go with the frequency or FREQ, new hash map. We are creating the hash map, the syntax. So this is fine. So we are making use of the hash map to handle the multiple same elements here. To handle the multiple same elements here, right? So this is fine. Now let's go with the simple while condition. This is q. If it is greater than 0, then what we will do? Let's go with the string tokenizer. So I'll just go with the string tokenizer variable. I'll consider st here. New. This one will be string tokenizer of br dot read line, br dot read line. So this is fine. Next line is, let's go with the op. So let's go with the op here. This one will be st dot next token, st dot next token dot. So this one will be char at 0. This is fine. So the next part is, let's assign the x to integer dot percent of this one st dot again next token. So this is fine. So yeah, next part is, let's go with the simple if condition. When the operation is plus, when the operation is minus, and when the operation is question mark. When the operation is plus, we have to increase the frequency and we have to insert only if it's the first time. And when the operation is minus, we have to reduce the frequency. We know this from the approach, and we have to remove only if no more x is left. So for the this one minus, and for the last one, when the operation is this one, what do we call question mark, then we have to get the maximum XOR with the current try elements, right? So we have we have already written this thing. What do we call operations, or the method insert, remove, and get max XOR. So that is the reason we will be making use of the same thing. That is the reason we have written these methods, right? Get x, this one, get max XOR, remove, as well as the insert. Let's do the same thing, man. Here, let's do it quickly, right? So if operation equals, so this one equals plus, then what we will do within the if condition, we have to increase the frequency. Nothing but I'll just go with frequency dot put here of this one is x comma uh, frequency dot get. So let's make use of get or default here, that is provided by the hash map, right? So this one is x comma 0, x comma 0 plus 1 means we just have to increase the frequency, right? So after doing that, we have to insert only if it's the first time. Let's write the one more if condition within this if condition, right? So here I'll just go with, sorry, if frequency dot get of x, if it is equal to 1, so try dot insert of x, try dot insert of x. This is fine. So we are just inserting only if it is first time, right? So this is fine. Next, let me go with else if here. Else if operation equals, so this one minus, then what I need to do here, so frequency dot put here, frequency dot put, so we have to reduce the frequency. We shouldn't increase the frequency here, as we are going with a, as we are comparing this one operation with this one, what do we call minus. So minus operation, we have to reduce the frequency here, right? So I'll just go with here. How can I write this one? I can just go with x comma, we have to get the value, right? So this will be frequency dot get of x. We are reducing the frequency minus 1. So minus 1. This is fine. I hope this works. Let's see. Uh, Now we have to remove only if no more x is left. So let me write one more, this one, what do we call, if condition. This is easy. So I'll just give here frequency dot get of x. So this one, if it is equal to 0, then we have to go with try dot remove, try dot remove of x, try dot remove of x. This is fine. We are removing only if no more x is left. So let me go with else if operation equals, so this one question mark, then what we have to do, we have to get the maximum XOR with current try element. So I can just go with out dot println. This one will be try dot. So let's go with the get max XOR operations, or let me copy this one. Let me copy paste here. This one. Let me copy this one. Let me paste it over here. Where is it? So yeah, let me paste it over here. So of x, this is fine. We are just getting the maximum XOR with the current try element. So we are done with this part. We are done with this part. Let me come out of this one entirely. Finally, we have to flush the output. Means I'll just make use of out.close or out.flush here. So I'll just go with out.flush here in this case. Right. So we are done with the coding part. So we are done with the coding part, right? So we went step by step. So whatever we discussed in the approach, the same exact thing we have articulated in the form of code here. That's it. Simple, right? So before what do we call? How do I say this? Yeah, before this one, what do we call? Before submitting the code or before checking with the this one different inputs to check whether the code works properly or not, let me copy paste the signature starter template. Just give me a second here. So here I'll just come here. Let me paste it over here. This is fine. Just ignore this one. Let's concentrate on the this one. What do we call? Logical part. So this is fine. I'll just come here. So let me copy this one. The output that we need to get here is 11, 10, 14, and 13. So let me paste it over here. Let me run this one. So we have got here, this has to be dot, not the comma. Line number 98. Where is line number 98 here? Yeah, I have to go with frequency dot get, not the comma. So yeah, we are getting the output 11, 10, 14, 13. So whatever the code that we have written works absolutely correct here in this case. Absolutely correct in this case, right? So let me copy this one. Let me come here to the submission part. So we have already selected D, Vasily's multi-set here. Vasily's multi-set. So let me paste it over here, right? So let me hit the submit button. So I hope this works for all the test cases, man. Let's see. So let's wait for some time. Let's wait for some time. So you can clearly see here running on test one. Let's wait for some time. This you can solve with the other methods as well. I mean other data structures as well, or the other approaches as well. So this is the best one I thought to explain basically, right? Along with the try. So this works well with the try basically, to be frank. You can understand the problem crystal clear rather than going with a different approach. In my opinion, you can just try it out with the different approaches as well, right? So you'll understand the try part better if you use try for this particular problem along with the this one XOR and other operations as well, right? So you can clearly see here in the tooltip it is showing accepted. So whatever the code that we wrote here works absolutely correct. The code got accepted, right? Whatever the code that we wrote works absolutely correct, right, for all the test cases. So I hope the solution part is completely clear along with the approach and the complexities, right? For now, this is it. Thanks for watching, guys.